Hello everybody, this is Mr. Gamboa with a last minute, study tips for the Unit 4 Proofs exam. So once you've done the practice exams A and B and even seen all the videos, you might still be wondering what else could I do to study? The things you could do to study were just to go over basics, right? Like basic concepts. Let me do this in, say, red, right? So this is I would say Unit 4 Proofs. Last minute, right? Last minute tips. So first things first, when we do our proofs, right, you should always have your strategies in mind. Triple S. What does that picture look like? So that would be a situation where, for example, you have this situation should be true. So after you marked up everything, you know for a darn fact that you have 3 corresponding pairs of triangles, okay? So I would say if before you're studying for this, you should know all the situations and know how to look out for them. There's triple S situation, right? There's the SAS situation. That might present itself maybe this way. We got vertical angles right here. And in so doing, right, that's another thing we should always recognize, right? Anytime 2 lines intersect, making an X, we have vertical angles, and we know vertical angles are always equal, so that's like a free A. And then for this to be SAS, we would need to see something like maybe this side and this side are congruent, maybe this side and that side are congruent. That's how the picture for SAS usually looks like, okay? We have 2 pairs of congruent sides and a pair of angles between those sides, okay? We also can have angle, angle, side, and angle, side, angle. What would those pictures look like? Maybe something like this. I got this triangle, it goes like that. Maybe the problem tells me that this point M is the midpoint from, let's say, B to C. And then here's point A, and let's call this point D, for example. So if they tell you that M is the midpoint, if it's literally given M is the midpoint, then I know to mark it up. If this is the midpoint, that means B to M is just as long as M to C, because the midpoint means it's halfway. It creates 2 equal sides. Another thing I could see, if this is a double AAS situation, I need to have 2 angles, maybe up here, right? Those 2 are congruent. Maybe they gave you that, like it's given that A is equal to D, angle A equal to angle D, and then you would lead one more angle pair, maybe this one, B and M. So maybe you also are given that angle B is equal to angle M. Okay? So in that situation, that looks like a AAS situation. I have 2 matching angles, and the side, note that the side is not between them. That's the angle side angle situation. Again, if you're watching this video and you're like, yeah, I know these already, that's good. Again, maybe this part of the video isn't for you. Angle, angle, side, what would that look like? And maybe if I have this kind of picture, if it's going to be angle, side, angle, that would mean, let's say this angle and this angle are equal. They have that shared side, and then maybe I know that this angle and this angle are equal, right? That's what the angle, side, angle picture would look like, okay? So you should have all these kind of pretty much memorized, committed to form, and last but not least, whenever I know for a fact that I have a 90-degree angle, right? So maybe you have like this kind of picture. And I know for a fact that's also a 90-degree angle. And I can figure out that this side and this side are equal. And at least one of these pairs, so maybe this one here, that is an HL situation, okay? So a reminder, when we have a right triangle, the longest side, usually across from the 90 degrees, right? The longest side in the triangle, that's called a hypotenuse. H for hypotenuse. Hypotenuse, longest side. And then the L is one of the legs, right? One of the sides of the right triangle. So if I can at least show that the hypotenuse is the same and the legs are congruent, we can use HL to say the 2 triangles are congruent, okay? Other things I should have memorized for this test. A common reason we use to show that 2 triangles are congruent, and therefore when we fold them over, we have kind of corresponding sides, is this acronym, CPCTC, right? We use it lots of times. Let's just not forget what it actually stands for, right? It spells out that the corresponding parts of congruent triangles are congruent. So that's the understanding that once I show that two triangles are congruent, quote unquote, they take up the same amount of space and are the same size, right? Like you can put one on top of each other, then any sides that are in the corresponding spots have to be equal. That's what the corresponding and congruent part, the first C and the last C are talking about. So you should have that ready to go at all times. Another helpful strategy is knowing how to mark up and make sense of the following two situations. So here's the first one. Let's say a problem tells me AB, CD, and then the double lines, right? A reminder, what does the double lines mean? It means parallel. So when I would draw A to B, right, like as lines, you're saying here's A and here's B. And when I draw C to D, I should draw it so that, at least to the best of my drawing ability, to the best that I can draw straight, it looks like those two lines never touch. Remember, parallel means that two lines never intersect. Two lines that never intersect. Intersect. There's an R in there. Intersect. All right. Now, why is parallel lines important when we do our proofs? Well, oftentimes one of the reasonings that we use is that there's like a line that cuts through our parallel lines, and it forms what are called alternate interior angles, right? In this situation, we would argue if AB is really parallel to CD, then this angle right here that I'm marking up in green should be equal to this other angle I'm marking up in green. Those are equal. This only happens every time I have parallel lines, remember? So alternate interior angles, right, are always congruent. So they are congruent when the lines are parallel, okay? So if a problem tells you something like this, AB parallel to CD, immediately on your picture, you should look for those two lines. You should add in the arrows. And then after that, kind of look for, is there any line cutting the two parallel lines? And if so, mark up the alternate interior angles, right? That might just save your life when it comes down to showing that I have an extra pair of angles that are equal, okay? The other situation, I think I have space right here, that shows up a lot, is what if the problem tells you MN, this symbol, and then CD? What does that mean? So for example, in this case, here's M and here's N. CD would have to, the picture would have to look something like this. Here's D and here's C. So what we're saying is from M to N, the line segment M to M touches line segment C to D, and when it does it with style. It creates two 90-degree angles, right? So a reminder, that symbol is the symbol for the word perpendicular, and it's something that we learned again at the beginning of class when geometry was nice and fresh and easy, and we're just really talking about drawing lines and stuff, okay? So perpendicular, it just means two lines touch. They touch at one point, and when they do, they create two 90-degree angles. So again, if that is in your given, the thing you should immediately draw is draw these boxes, right? Even shade them in. That's free points that you should be getting, okay? What I do not want to see you do when you do this is something like this. I don't want you just doing angle markings like that, okay? Because although these two are congruent because they're both 90 degrees, it's not the correct way to mark it. Perpendicular means it makes two 90-degree angles. So don't draw just the angle congruence symbols. I want you to draw the boxes, okay? Well, that said, right, if you're still watching this video, let's just do a quick proof together. And then I would say beyond that, maybe look up more YouTube videos of triangle congruence proofs and just review your notes, okay? Let's do a problem. We'll review the 4-step process, and then we'll take it from there, okay? So here is a problem. One more problem to study. Okay, so let's say you're given the following information, and let's say you're asked to prove the following thing. Okay, let me draw a situation for y'all. Maybe we have this going on here. Okay. So I drew this kind of funky box. I gotta add some letters to this. This top corner is A, this top corner is B, this bottom corner is C, and this bottom corner is D. This point from A to C, and from D to B, where they kind of cross paths. Let's call that M. So if you're at home, I want you to, first of all, draw that picture. A, B, C, and D, M in the middle. Let me give you some information. So one thing that you're given is AB is parallel to DC. Okay? So if this is you taking the test, if you read that and you have that picture, the first thing you should do is mark it up. What does it mean for AB to parallel to DC? It means you should be marking up the following little arrows, okay? Good so far? The other thing I'm going to ask us or tell you that is given, the other given piece of information is I'm going to let you know that AC, segment AC, bisects segment D to B. Okay, so this line here, AC, it bisects segment DB. That means it cuts it into two equal pieces. So the way I would mark that up is, again, DB is the thing that's being bisected. Bisect means cuts into two pieces. So I would mark this up maybe like this, okay? That's why the original DB cut up into two equal pieces. That way there's two congruence markings, okay? And then the other piece of given that I'll tell you is that AC, right, this line, cuts this into two equal halves, but the vice versa is also true. The other thing I'm gonna let you know is that segment DB also bisects segment AC. Okay? Now you might say, Mr. Gamboa, that it sounds like you're just repeating what you said, but no, actually it's slightly different. What's being bisected now? Segment AC, right? So from A to C, I'm saying that's getting cut into two equal halves by DB. So I'm going to put two angle markings here and two angle markings right there. Okay? Now last but not least, what am I actually going to ask you to prove here? Can you prove to me that triangle, let's say BDC, is congruent? So by BDC, I mean like this big triangle here is congruent to triangle ACD. ACD. So there's a, let me highlight the triangles in question. When you're taking your test, again, you're entitled to a highlighter. So if you want to highlight anything like that's being asked to prove to help you, you should. So BDC, I'm saying this big triangle on the right, okay, is congruent to, and let me use a different highlighter for those of you watching at home, ACD. So A to C to D. So this one on the left, okay? Okay. I want to show that those two are congruent. So let's just think about what we can do. This one, let's do it as a flowchart proof. I haven't done enough of those with us. Okay. So let's think about what we need to show. Well, on the one hand, because these two things are parallel, right? Let's mark up the alternate exterior angles that we were talking about. Let me zoom in a little bit here so it's a little bit easier to see on the camera. Okay? So as I said, anytime we have parallel, we should be marking up any alternate interior angle. So I know this angle, right? It's congruent to that one. What else? Again, because these are parallel, these are also alternate interior as well, right? Okay. So let's start using that. On the one hand, right, if I want to show the big two triangles are congruent, what I could say is, because this angle and this angle are angles, and this side are congruent sides, and maybe some of you are pretty keen. I've used two angles, so let's use three. I know these angles are congruent, right? Because these are vertical angles. Let me start labeling stuff. Those are vertical angles, right? I know those are congruent. And I know this right here is an alternate interior angle. Same thing here. Alternate interior. Okay, so these two are alternate interior, these are vertical. But let's kind of zoom in on something we can show is true. I know this angle, this side, and this angle match up with this angle, this side, and that angle, okay? So at the moment, what I can say, right, is this triangle here, the middle one, which I'm shading it in orange, has to be congruent to this other triangle, which I'm shading it in orange, right? Using angle, side, angle, right? These alternate exterior angles, these congruent sides, and these vertical angles, right? So one step we could show is, hey, reader, right, these two are congruent. okay? Now, on the other hand, let's see, I'm gonna have to use another color. Let's use maybe blue. On the other hand, let's kind of take a look at triangle AMD and triangle BMC. Is there a way to show that this left and right triangle are congruent? Well, let's take a moment to think about that. Sorry, the video's still going. I thought the camera shut off. So one thing we could say is, hey, like these two sides are congruent because this has 2 tick marks and 1 tick mark, and these two sides are congruent because this has 1 tick mark and 2 tick marks, right? Just as we said before, here I'm gonna have to use like 4 angles. 1, 2, 3, 4. Why are these 2 angles congruent? If you're watching the video, let me zoom in a bit. Yeah, why are these 2 congruent? Again, they're still vertical angles, right? So what I could say is this big left white triangle is congruent to this big right white triangle as well by side, angle, side, right? Side, angle, side. So at that moment, like I said, let me use blue. Using side, angle, side, we could show that, hey, this triangle has to be congruent to that triangle, okay? So we have a congruent orange triangle on the top and the bottom, congruent blue triangles on the left and the right. How will this help me prove that the big green one has to be congruent to the big blue one? And maybe take a moment to think about the picture here. I'll zoom in, and hopefully, if you got a little bit of, elementary school like common sense, you can guess the answer, right? And there shouldn't be any guessing, right? The big green triangle is made up of the orange bottom triangle and this blue, right? Hi there. I'm not sure where the video stopped, but so far we're here, right? So, argument, right? We show that the 2 orange triangles are congruent. We show that the 2 blue triangles are congruent. Therefore, we can say that BDC is congruent to ADC. The big green one is congruent to the big highlighted blue one because both of them are made up of an orange and blue triangle respectively, right? This one's made up of 2 pieces, and that one's also made up of the same 2 pieces. So we were here. We explained that the 2 orange ones are equal by ASA, and now we just needed to explain why the 2 left and right triangles are congruent. So let's get to that. One of the pieces of information we used is that these 2 sides are congruent. Why is A to M equal to M to C? From there, we kind of draw that here, right? Because we know A to M equals M to C because they make up segment AC. That's the definition of bisect. Definition of bisect. Okay, that provides us an S in showing that the left and the right triangle are congruent. After that, we could also say, hey, we got another pair of vertical angles. We had vertical angles up and down, but now we have vertical angles left and right. So that would be described AMD. Let's write that over here. AMD as an angle is equal to, let me go back to the picture. AMD, so the other vertical angle is BMC. So we would say BMC. We're saying these 2 vertical angles are congruent. We'll say vertical angles, right? So we have an S, that gives us an A. And then going back to the picture, we know that these 2 sides are congruent. We know these angles are congruent. And then why are these 2 sides congruent? From D to M and M to B. Note before, we've used that reasoning before. D to M equals M to B because DB was bisected. So we'll put that here again. D to M is the same thing as M to B. Again, definition of bisect. Definition of bisect. Okay? So that gives us our last S. Okay? So we are reusing the same reasoning twice. Okay? Once for the orange triangles, and here for the blue triangles. Okay? So therefore we say SAS, SAS, left and right triangle are also congruent. So we would say by SAS, we can put these things together and say triangle AM, leave that there, sorry. AMD is congruent to AMC. AMD equal to triangle BMC. This time it's by SAS congruence, okay? So at this point, if I kind of zoom out and we have our madness spelled out here, on one hand, we use an ASA proof to show that the two orange triangles are congruent, and on the other hand, we use an SAS proof to show that the left and the right blue triangles are congruent, okay? So at this point, we can link up this angle side angle and this side angle side, this ASA and this SAS, for one big conclusion to explain to the reader that's why triangle, BDC has to be congruent to triangle ACD, right? My reason there, however, right, I would explain this because BDC is made up of orange plus blue, so we'll say because triangle BDC and triangle ACD are both made up of, right, an orange triangle and a blue triangle. So we're saying an orange triangle plus a blue triangle. Okay, and that would end the proof there. Okay, so this time it isn't CPCTC. We're just saying this green triangle is made up of an orange and a blue one, but this bigger, highlighted, it's almost like a baby blue highlighted, right? It's also made up of an orange and a blue. That's why they have to be congruent, because congruent shapes take up the same size and same shape. Okay, so that explains the proof there. Okay, so obviously, if you are watching this at home and you're asking yourself, Mr. Gamboa, is this going to be on the test? No, not necessarily. This one was kind of involved. This one I could expect you guys to do for like a homework problem if I give you enough time. But what I want you to take away from here is the reasoning here, okay? What we did here in this problem is we did the 4 steps. Step 1 was take the given information and immediately mark up the problem. Do that again on the test tomorrow. You'll lose points if you don't mark it up, and they're easy points, right? Later, one thing we could have done, irregardless, even if we don't know what's going on, is once we marked up the problems, if it's a flowchart or if it's a 2-column proof, remember the first couple boxes in a flowchart proof, just copy what the given is, statements and givens, right? And I know at the very end, even if I didn't come up with all of this logic in the middle, I know the very last box has to just take whatever they asked us to prove, put that there, and then supply a reason, okay? So even if you are very confused and don't know what's going on, you can always get those points there, okay? So again, happy studying. Whatever you guys end up scoring, just know that this unit of geometry will be over at that point. If you end up doing badly, that's okay. Life will go on. You'll get a chance to get your grade back up later, like I said, by doing better on the final exam, okay? So a reminder, there are no retakes in the class. If homework is late, it's late and you lose 50% of your points. That's just the expectation I want you to have for this class, as you will have in the real world. There's deadlines, and sometimes you have a big exam or a big interview, a party. I know some of you guys are doing quinceañeras, those who do that kind of thing, right? Like there's always some event in your life that you need to prepare for. You study for it, and then hopefully when life hits you with that challenge, you're ready for it. But even if you're not, you learn from it and you keep going, okay? So at least for the geometry class, right? If your grade's not good right now, don't worry. What I want you to know for a fact is when it comes time for the final, that is your last chance to get your grade up, okay? If you score better on the final than you have as an overall grade, I can respect that you've did your studying, you caught up, you learned from your mistakes, and I can bring your grade up, okay? So look forward to that, to help redeem you. But in the meantime, you have nothing else to do but to study. Bye, y'all.